Saying another welcome to everyone who's joining us. We have a lot of folks registered for this roundtable, so we're really excited to see you all this afternoon here in Massachusetts. It's cold and icy Massachusetts as it's the depths of winter here. Having to be very careful walking on our sidewalks right now. We welcome you to the roundtable and invite you to just introduce yourself in the chat. Say hello, say where you're from. We have a nice mix of people from all over the world joining our roundtable today, so we really appreciate you making the time today. We're going to give it just one more minute as people join us, just to make sure we have everybody who's able to come today. And as we're waiting, I'm going to encourage you to, if you would like to change your view, if you look up at the top right of your screen, you should be able to change your view so that you can pin the speaker. And because we do have a lot of people registering today, we would ask that you, once we get started, that you turn off your video and you can pin the speaker view, and that way you'll always be able to see our wonderful panelists as they're speaking with us today. So great to see you all. See, we've got Tara, our wonderful implementation and technical coordinator, hailing from Kentucky. Good to see you all. We have a huge Italy contingent, so welcome to Italy. We know that our panelists are really excited to have you join us today, and we're excited too.
Those are our supporters.
That's right. It's your cheering section. I see We've got Los Angeles in the house. Hi, Karen. Good to see you.
Hello. How are you doing?
Doing great. We're so happy to have you all. Gwen Shipley, happy to have you here from Waltham, Massachusetts. I'm another Massachusetts person. I saw you nodding when I was talking about the snow and ice. So good to have you here. And we're at about 3:01, so I'm going to go ahead and get us started because an hour is really not very long when you have as much to say as our wonderful team has to share with us today. So first of all, I would just like to welcome you all and thank you for coming to our 4th installment of the ABE Teacher Roundtable Series. For those of you who don't know me, I'm Jessica Juliuson. I'm the Director of Professional Development and Networking for ABE Program Office. And these roundtable sessions were originally designed specifically for our ABE Master Teacher Fellows. But this year, we wanted to open them up to our incredible ABE teacher community from around the world as a chance for all of you to learn from each other about topics that are of specific interest to science and biotechnology teachers. So we hope you find this series valuable. As you listen, feel free to tag us in social media if you want to share your thoughts. You can use the tag @ABEProgOffice. And maybe Amy can pop that in the chat so you can all use that if you'd like to do so. This roundtable is going to be recorded and we're going to post it on the ABE website, and registered participants will also receive a transcript at the end of the discussion. And we will have some time for audience questions at the end of the presentation. So please, we encourage you to put your questions in the chat at any time during the discussion, and we'll be sure to watch for those and to ask your questions at the end. So I want to begin by just saying how pleased and excited we are to be hosting some of our wonderful team from ABE Italy. For those of you who have been with ABE for a while, you may know that this team has been doing incredible work developing such a strong community of practice among their teachers within ABE schools. And today they're going to share with us some of their work and insights in how to develop teachers' capacity to really transform traditional science teaching and to better integrate an inquiry-based approach. So in today's roundtable, our colleagues will discuss what inquiry-based science education, or IBSE, really is, why IBSE matters, what teachers need to know to facilitate it, and they'll share with us some real examples from their teachers. So without taking much more time, let me quickly introduce our distinguished roundtable panelists. With us today, we have Dr. Anna Pascucci, who is the site director for ABE Italy, and Anna serves as the national vice president for ANISN, is a supervisor at the Inter-University School of Specialization in Teaching in the University of Naples, and is an evaluator for the National Institute for the Evaluation of the Educational System of Education and Training. Thank you, Anna, for being with us today. We also have Dr. Luigina Renzi, site coordinator for ABE Italy. Luigina serves as a board member for ANISN and is the representative for Italy in the panel of experts in biology for the baccalaureate exam in European schools. Dr. Mariangela Fontechiari is the regional coordinator for ABE Italy. Mariangela is a teacher, trainer, and is responsible for the ANISN IBSE Center in Marsh. She is passionate about professional development for science educators. And last but certainly not least is Dr. Chiara Garulli, the didactic committee lead for ABE Italy. Chiara is a teacher, of course, and trainer. She has collaborated on professional development projects for science teachers in IBSE under the guidance of the Italian Ministry of Education. So we're so happy to have all of you with us today. And I'd like to just begin by asking each of you to say a little more about your role and why you think inquiry-based science education matters right now. So maybe I could start with you, Chiara.
Yeah, in our world, science is in full revolution. New discoveries become old in few years, and theoretical content are shared faster through internet. So teachers can no longer be considered the person who knows the subject and transmit this knowledge. Our role as a teacher is becoming more difficult, but in my view, more exciting and also socially required. We need to give our students the skills to read their own realities. I try to be more clear. I'm thinking about a video in which a professor was showing a microscope slide and claimed that after water evaporates, under the microscope, a microchip appears in the form of some square structure. Watching this video, I assume that all people wonder if all microchips are squared, or if why this structure appears only without water. Also, why does not this professor show a real microchip under the microscope to make a comparison and prove that what is being observed is real? I take this question for granted, but it's a matter of fact that many people watch these videos and believe what they see, because in my view, people are not used to inquiry. So, it would be one of my worst nightmares if one of my students watched this video and believe it without any question in their mind. With IBSE, we not only teach the content, but also we try to develop in our students an habits of mind. And for this reason, I think that is crucial to use this kind of approach.
I love that. And I think that's a message that resonates with so many of us right now, this idea about getting used to inquiry again. I wonder, Luigina, would you like to respond to the same question? Why do you think inquiry-based education matters right now?
Sure. Thank you for having us. It has been a great opportunity for us. And we have been working in IBSE for many years now. And our idea is that the inquiry is an extremely powerful approach, because students can evaluate and make decisions based on their own evidence. So they're not only a student that perform a protocol during experiment, but they think about the experiment, think under a different light, and they show evidence. They have to explain their evidences. And learning through scientific inquiry may be synthesized as the process. It's a real process of building competencies, building understanding through the collection of evidences. And this is how to say, it's a message that the students will take in their history. It's like part of them. It's not something that they learn by heart, but they experiment and they think and apply after that. So I think this is an extremely powerful approach also for students that they are not, how to say, perfectly bright or perfectly clever in some other situation, but they find their own way in this context. So I think it is extremely valuable approach and methodology.
I love that. I love hearing about how students can use those muscles in different ways. And maybe that's
Right.
not the muscles they think of when they think of doing
Right.
science. So Anna, what are your thoughts on this? Why do you think it matters right now?
Yeah, first of all, thanks to everyone to be here. What I think why inquiry-based science education approach is important, I think because there are three fundamental things. Because IBSE develops in students a basic understanding of what science is, how it works, and its strength and the limitation. And this is important not only for students, but for all the citizens. And the pandemic, we have seen what has happened with the pandemic. So there are not only the development of the ideas of science. I mean, ideas of science means contents, but better, I prefer ideas. So in this way, the idea from smaller, they become bigger and bigger as the students, and deeper as the students get older. And not only of science, idea of science, but about science. So this is a way to foster the process of learning through understanding, or with understanding. So it's a method of thinking. This is my key point.
I love, and so, it's such a theme that I've heard across your three answers, which is that it's not about following a list or following a recipe. It's about the why and the kind of critical thinking about the process and understanding how they fit together. And so I wonder, a lot of us use the term inquiry and inquiry-based science education, but what is it? So how would you define it, Anna? What makes it different from other kinds of science teaching?
Yeah, it's not easy to define inquiry-based science education. You can find a lot of definition and statement and so on. I prefer to say that inquiry-based science education means that students develop progressively key scientific ideas through learning how to investigate and build the knowledge and understanding of the world around. This means that they will develop the skills employed by scientists, like raising questions. Luigina, can you go? Thank you. Raising question or collecting data and reasoning, reviewing evidence, and of course they discuss, drawing conclusion, and so on. But the point is that's not just a list of skills. This is a list of skills, but to foster these skills, you need the process that normally we call this process learning through scientific inquiry. It means that, of course, you start with a new experience, a new question, and so on, and you explore possible explanation, alternative ideas, existing area, bigger idea, and so on. During this process, as we will see during this roundtable, the teacher change its role, the dynamic of the whole class, and so on. And this process is a recursive process. So in this way, each time you go deeper and deeper, and in the same time, the students develop the skill better and better.
So it's such a
but I have to say, please, Regina. But what I can say really is that you need to plug into inquiry-based science education at first person. So for us, it's a sort of diving into the blue sea, but of course you need not to be alone. So you need a learning community that supports you and a sort of environment of trust and you can share, you can be supported and so on. You need selected tool. Of course, you can find any kind of resources on web and so on, but you need selected tools that can support you in this learning of this kind of teaching. And then, and of course, to do this, you need opportunities to, so PDIs for inquiry-based science education, and not just one time, that the progressive, just one time, that's all. So what I can say really is inquiry-based science education, this is not because we are passionate, but that we can share this with other people, is really an intense and addictive experience, I think. So
I love the way you describe it. I love that it's sort of like the air you breathe has to be supportive. And so it has to be a safe environment for teachers. They need to have the right resources, but that once they try that, it's something that you want to keep doing. And I just, I wonder, because it seems so, you need to have kind of a spirit of asking questions. And so I wonder what makes a good inquiry question? And I wonder, Marie-Angela, could we turn that question to you?
Okay. Hi, everyone. As a teacher, I always pose questions to my students every class. And I'm used to ask different kinds of questions and for different purposes. I think that for a teacher, questions are one of the main tools of the trade. And it also applies to the inquiry-based and teaching learning. This is a natural consequence of the close connection between the inquiry learning and the scientific process. All inquiry, both scientific inquiry and inquiry learning, begin with a question, a research question, that is the engine of the process of making science, and the process of teaching science with the inquiry approach. But not all questions we ask to our students drive an investigation. In this case, they are not a good inquiry question. So productive questions for inquiry are, first of all, investigable questions. I mean questions that lead the students to action, the same action that scientists are used to take. And for this reason, investigable questions require to use process skill, such as observing, making measurement, and so on. So basically, investigable questions are those that allow to collect and analyze the data to find out the possible answer. Please, Luigina, thank you. In order to generate a good inquiry question, I usually follow some criteria that work as the items of a checklist in my mind. So, good inquiry questions are not a simple request for information that can be found from a book or the web. They are neither too general nor too complex, such as the question that begin with why. They are not a question that can be solved by yes or no answers. They are simply formulated questions. I mean, questions that are clear and easy to understand, are referred to real context, relevant situation. So they are meaningful to students, they are engaging, they are challenging, and they are new to students. This last point is very important in order to ensure authentic experience, authentic investigation for students. And now just a few examples of right and wrong question for inquiry. The first one, why are enzymes essential for cell? Is a why question. So it is too open and too complex to be solved by performing an investigation. It rather requires a theoretical explanation, a complex explanation. So the second one is much better. What happens if a chemical reaction occurs with an enzyme? This is better because it is more well focused than the previous one. The next question, is cell membrane semi-permeable? Is not a good example because it asks for a yes or no answer. But it can be rephrased. It can be turned in a good question such this one. How can I determine if cell membrane is impermeable? Okay. Formulating good inquiry question is not a simple task. It is very demanding, but it is not impossible. So don't worry. As a teacher, we can rely on different support. For example, there are some effective techniques to turn non-investigable questions in investigable question. One of them is variable scan. And the strong suggestion, I think that is take action at first hand. Try to formulate inquiry question. Try and try again.
It's such a great point that, you know, there's an art to asking a good question. And I loved seeing you kind of walk through a real example of what makes one good or not so good for students. And I see we're starting to get some questions in the chat, so keep those coming. We're going to pull those out and we're going to ask your questions at the end of this roundtable. So in the meantime, it sounds like this means teaching might feel a little different. So, you know, this might be kind of a new thing that you're asking of students as opposed to just kind of giving back an answer or describing something. So I wonder if I could ask you, Chiara, to speak a little bit to how does the role of the teacher change when you're teaching in this way, when you're trying to embed, integrate IBSE?
Yeah, you know, as was said before, inquiry-based education is a process. And the aim of this process is that students become more independent learners. But this aim can be reached only if also the teachers change their way of action. So teachers should acquire the confidence to allow the students to develop their own ideas. This means that the big change is the relationship. So the teacher and students relationship is the big point that is changing during this process. So teacher from the normal teacher on the desk became a facilitator. So an help that guides students on their own reasoning. And in this way, teachers lead students to develop the skill of inquiry and the understanding of science concept through their own students' own activity and reasoning. This could be involve facilitating group work or dialogue on discussion, because you know, science is a group work. There is a community, and with this kind of process, students do the same things that science do. And I think that this is really challenging for a teacher to change this role and become facilitator, but I think also that is the real key to give our students, to empower our students.
It really is such a different approach. And you know, I find that even my daughter tends to resist this kind of not straightforward question. You know, she likes yes and no questions and to fill out, you know, a worksheet. And so learning to encourage students to develop these inquiry skills, it really is something that requires teachers to change their practice and to think about facilitation rather than kind of telling. So it's so great to hear you bring these things to life. And so I know that you're actually going to share, your team is actually going to share with us an example of how you've actually brought IBSE to life with an actual project and kind of walk us through what that transformation looks like. So at this point, I'll turn it over to your panel to show us what this looks like, from professional development all the way through to some project examples. So Anna, would you like to begin by talking a little bit about what professional development is needed?
Yes, just to synthesize, we think that innovation succeed when the teacher became develop ownership with innovation. Is not something that just they are not target of the innovation. So what we have tried to do with our PDI, and this is the summary, of course, of the meta process in some way, is the first step is the understanding. It means that the teacher know about inquiry, what inquiry is, what's not inquiry, question, and so on. So inquiry as a teaching methods. And we do this through short talk, example, of course, assessments to understand, to support the teacher, the understanding. And then after that, we go to the awareness. So the teacher have to develop their awareness about inquiry in this approach. We do this through analyzing some ready-to-use resources, video or document. Of course, we give them a checklist and so on. So they have different examples, different testimonies, and also a time for self-reflection, group reflection, and then sharing. This is one of the important time for sharing, to develop a sort of to be in an environment of trust, as I said before. And then there is the ownership. So after that, you have some we support, and they can share through group work and so on. Some they adapt some activity. We give them some feedback. Of course, this is possible only creating a learning community. That means a smaller learning community with your colleagues at school, or bigger and bigger and bigger. So in this way, we try to do this. Teacher know first about inquiry, then they know how inquiry work, then they get inquiry as habit of mind. This is our strategy in some way. Of course, this is a recursive process. It's not just a list like the skill of the students, and are interconnected step. And so during our PDI, of course, it is important that this PDI is engaging, is collaborative, is recursive, but it's not just word. We really do this with many strategies and many kind of sharing. And you can see some flower here because we have called our model as Daisy model. This is a way, a friendly way to show something quite complex that we have done. And about the result, we have results that after 1 year, about the 70% of teachers that have attended our PDI, they tried inquiry really in at different level. So they do this. Please, Luigina, and now Luigina will show our DAISY model. I think that is the better way to show, to share.
All right. Can I go ahead? Is that okay,
Jessica? That's great. Go ahead.
Okay.
This is wonderful.
Okay. Thank you. And this is the DAISY model. Actually, it was fun when we were preparing the slides about a year ago, and it came out, our model, like it looks like a daisy. So maybe it's because, I don't know, maybe we are romantic, but we like the idea that it's blooming something, the flower is, you know, blooming. So what we did actually is to use our IBSE model in the IBE, Amgen Biotech Experience laboratories. And the idea came out because we wanted to do the IBSE method with the ABE. So at the beginning, at first sight, we thought that this could be a great opportunity to use IBSE to transform Amgen Biotech Experience laboratory in IBSE laboratory. So basically what we do in our PDI is to discuss about the key element of IBSE, then talk about the nature of science, make observation, hypothesis, and prediction, and so on. We work on productive question, as Mariangela just said. Then we try to structure an inquiry activity, and we discussed with the during the PDI with the other teacher how to structure an inquiry activity. Then we didn't talk tonight about the inquiry levels, but that's another idea, just to start from very basic confirmation level of inquiry and then go forward and forward towards the more structured and open levels. And another very interesting point is to transform traditional activity in inquiry activity. We all are full of protocols, but sometimes students are not satisfied of these protocols. It's like, okay, but we see this. The other thing is to instead engage them in changing their mind, transform traditional activity in inquiry. And during our PDI, we do the methodological part, and together with the lab 1, lab 2, lab 3, which you all know about the laboratories, about Amgen Biotech Experience. And what it came out time by time is that we can perform some IBSE activities to introduce, to work with, or to elaborate. It's kind of a transformation of Amgen Biotech Experience laboratory in a more inquiry methodology laboratory. So what came out that we can do some activities like number 1 on micropipetting, which was developed also by another colleague, which is Rossella Lupo, who I saw her before, which I really thank her for her effort. Then the other activity was to explore food dyes with molecular lens, that you will see. Then another activity which are already in lab exchange is the construction of a gel, just to make a pudding in your kitchen. You probably have seen, and you could use this in lab 2, where we talk about electrophoresis, but also in lab 7, when we do the PCR, when we run the PCR product. Then the other activity Number 4 is the designing of a recombinant plasmid by a paper activity. The other activity, which is written here, number 5, is the regarding the exploration of variables which influence enzyme activity, for instance, temperature. And this is as well in lab exchange classes that you can use here as well in lab 3 and lab 6. The activity number 6 instead is more related to lab 4, which is the comparison of a different separation method. That you can see also it can be used in lab 4 and lab 8. So as you can see, it comes out like a blooming daisy model, which we think it was a lot of fun to work on this. It was a lot of thinking, but also a very creative way to use the IBSE method together with the ABE labs. And okay, that's number 7, which is the discovery of a secret of a band. Sorry, I forgot about this. So to do this, we used methods and tools. For instance, we did individual and group works. We shared findings. We did a lot of hands-on activity. And the tools was a questionnaire, Mentimeter, Google Forms, Padlet, Kahoot. So all kind of tools that can be used because this PDI in the past 2 years were done basically mostly by, online, remotely. So these tools were really useful to, keep our community growing. Okay, I am done.
This is so exciting, Luigina. I just have to say it's so wonderful to hear it come to life, and also to hear how you kind of turned the need for virtual PDIs into a plus, and that you are still able to continue to explore ways to adapt each of those labs. So we really appreciate the examples, the specific questions, and also the integration with Lab Exchange, which I know a number of our teachers are using, and certainly it's being used really extensively in Italy, in ABE Italy. So thank you for that. And so Chiara, we have, I don't know if you want to say any words of introduction first before we show your video, but Chiara's got an actual example of the transformation of a project and how you would actually go through that process. So Chiara, do you want to say anything, or you want us just to go ahead and start the video?
I don't know, this is a practical activity in integrating IBSE approach with the Lab 1.2 of the ABE curriculum. And I'll do this one with my classes for the last 3 years. And I think that I hope that you find inspiring and useful for you this video. So this could be enough, I think.
Hi, my name is Chiara, an Italian teacher, and I belong to IBSE of Italy and to the working group on the integration of ABE curriculum with IBSE approach. Today, I would like to share with you a possible way to integrate ABE labs with the IBSE through a practical example developed with classes. I strongly believe that it's worthwhile to design lesson activity with IBSE in ABE labs as well, as through this way of learning and teaching, students are actively engaged in the exploration and inquiry. They search for their own strategies to solve problems. They discuss and cooperate to make prediction and conclusion on the basis of the evidence they have found. In short, students put in action the real scientific process. In particular, today, I would like to focus your attention on the ABE Lab 1.2, the electrophoresis with dye. In this activity, students learn how electrophoresis works by incorporating some IBSE features in this activity, they directly discover the principle on which this technique is based on. And this causes a long-lasting understanding. How can we insert these features? The starting point is a problem. So, oh my God, Professor Garulli's dice got mixed up. And so, please help me. And so they find a box in their place in the lab, and inside the box they will find three Eppendorf with a blue liquid, and 4 cards that represent the molecule that were there before. In each card there is the structure of the molecule with also the charges and the molecular weight. Probably you already noticed something strange. I say 4 molecules, but you will see later why there are 4 molecules. At this point, I introduce a key moment for IBSE approach, the investigative question, that in this case is which molecule are there in each Eppendorf? They can answer directly to this question. So to guide them, I promote a brainstorming to encourage students to think a possible strategy to solve the problem. Students at this point use their prior knowledge. For example, they might think about chromatography, which is something I have already done with dice. This exploration was developed by our amazing colleague Rossella Lupo with her classes, and was based on an experimental comparison between these 2 techniques. Personally, in the previous lab, I performed DNA extraction from fruits, and at the end of that lab, I told them that if they want to separate different DNA molecules, they have to use a particular technique that is called electrophoresis. So at this point, if any of them listen to me better than my husband, they will say something like, Prof, you know, the technique you told us last time, or better, Prof, last time you mentioned electrophoresis. For the last 3 years, these strategies has worked, and so yes, students listen better than husbands. At this point, when this name come up, I give them the meaning 1 electrophoresis and show them that it takes electric current and gel made like a padding, and whose function is to create a matrix in which molecules can move. Now, at this point, they are ready. They have all the equipment to work with their beautiful brains. And so I give them the task. The task is to produce a paper gel using the cards of the molecules. First, each on their own, then in a small group. They have to come up with a shared solution. And during these 2 phases, students make prediction without teacher involvement. When the task is finished, you can move on the experimental part or have a class discussion where each group show and comments on the paper gel. Class discussion prior to the experimental activity helps students compare their reasoning with that of their classmates, and this sparks their reflection on what they have done. Teacher can choose whether it is important for them to share ideas or for each group to continue with their own thoughts. I personally have always done this phase before experimental activity. Although the experimental part in this activity is fairly simple, as they have to make a gel, it also contains a research question. Where should they put the comb? And this hidden question is the reason I included the fourth molecule. In my first year of ABE, one of my students, Nico, put the comb in the middle of gel, saying that it had not already been experimentally proven that all molecules would move in the same direction. And you know, in this situation, the students became the teacher. I liked so much this observation that afterwards I inserted the positive molecule in the protocol. After the run, students have to associate the colored bands with the correct paper molecule. They do this by adding the observed color on the molecule on the paper gel, and then show the results in class discussion. Usually, everyone recognizes the positive purple molecule and the orange molecule, but the other two molecules are not associated in the same way in all groups. It depends on the variable they consider, charge or mass. In the discussion, they should try to find a solution, but if they don't agree on the explanation, I can help them. As you can see, the teacher does not correct student strategies. His role is something like a facilitator, and probably now you are thinking, and if they make mistakes, yes, they make mistakes. But you know, in science, every mistake is a wide opening to reasoning and also to discoveries. So don't worry, and let them be free to make mistakes. And you know, I hope this experience will be inspiring and also useful to you. Thank you for your kind attention. I hope to get your feedback and would like to share your experience. Thank you so much.
Chiara, thank you so much. What a wonderful presentation that was. And there's so many specifics, so much to chew on there. And so for all of our participants, please know this roundtable will be posted on our website. And with the permission of the ABE Italy team, we'd love to share your video, Chiara, so that teachers can look at that at their own leisure as well. So I kind of want to follow up. We have a couple of nuts and bolts questions in the chat, but I want to follow up on what you just said there, which is that you know, students need to be able to make mistakes. And I know one of the things that a lot of our ABE teachers have shared with us is that students are really afraid to make mistakes, and teachers are sometimes afraid to let them because of assessment and evaluation and how job performance is measured. So thinking about that, how do you approach, first of all, as a teacher, how do you approach building confidence in your students to fail, that it's okay? How do you create that culture? And I would ask also, how do you prepare your teachers for that through your professional development? And so maybe I could start with Chiara. How do you, as a teacher, prepare your students?
Probably is the relationship. When I go to the lab, my students know that this place is a particular place, is the moment in which they can think there is no mistake, because every experiment, there is not a right or wrong. There is one thing that is not that has to be think more deeply, and one thing that is only superficially reasonment. So I think that is the process. When they are very small, they have fear of the teacher, of the evaluation, and so they did not speak. But if they grow in this kind of environment, they became more free also in the class when you explain or you make other kind of interaction, other kind of lesson. So it's not only in experience, in the experimental experience, but is the way in which you grow them and in which you interact with them. So I think that the key is this one. And also the fact that they can interact each other among peers. So they can look to the strategies that other develop, and they learn each other from what they done alone as a class.
And what I can say that, of course, also during the PDI, the mistakes are an incredible opportunity to learn more, to go deeper. So if you create a sharing, a real sharing, a learning community, the mistakes are incredible because points how science work, and so understanding the mistake means to go in deeper in science and probably discover much more. So there is no answer. It's the same. All the things are connected, because in science education is an approach. So also the question, yes or no, are not question, are not inquiry. There is nothing that is true or false in science, in some words, in the future.
And you were breaking up a little bit, Anna, there, but I heard two things very clearly. One was that you feel that this culture of a learning community, peer-to-peer, is so important in both the classroom and for the teachers as they're learning to facilitate in this way. So developing that kind of environment where it's safe and where the emphasis is on process and the questioning and the process of going through inquiry rather than the answer itself. And then the other thing was that yes or no questions don't cultivate that and don't cultivate that kind of practice. So I hopefully we were able to catch most of that through the audio. And we have a couple of questions from our participants. We have Gwen is asking from Massachusetts, and we can tell, Gwen, you are an ABE teacher looking to adapt ABE. So Gwen is asking, is there a list of good inquiry questions? And I know you shared some of those. And then as a follow-up, would you be willing to share the protocols for your 7 inquiry questions? So the ones that you shared on the slide with your blooming daisy. Is that something that you'd be willing to share with our participants?
Of course, absolutely. Yes, there is no problem. We are absolutely willing to share. We are here for sharing and hear your feedback. So absolutely, of course. And the other thing I want to add is that we, as a teacher, we should stop to be judging. That is something very annoying for the students, because we think that they have sort of a medal, you know, you are A, you are B, or you are C. But this, we don't have, I mean, we have to stop. This is kind of our power to be, you know, the judge, but this is not the way that they learn, because they are afraid of our our judgment. So I think we have to do that, but it's not all it is. And it's the fact that people can be wrong. We should kind of empower them to be, how to say, safe and relaxed, even if they're wrong, because there is no wrong or right, as Chiara just said. So I think that we like judging, but if we stop judging, we work better and the students learn better, not with fear. So that's the point. Yes, of course, you can have everything. Anna will send all the, you know, all the materials and everything, and be happy to share with you all, and listen to your experience as well whenever you know are tried or you want to practice.
Thank you so much. The team has been incredibly generous, and I want to share that not only will we share their materials with you, but they are also working with the program office to develop a course for inquiry-based science education that you will be available to all of your program sites. For all of you who are ABE teachers, your program sites will have all of these resources and materials available to them. So we're hoping that that will come out sometime, hopefully by April. And don't quote us on this, but it will be coming sometime between this spring and early summer in the US. So it'll be available to all of our program sites. Karen asked a good question, and I think you touched on this in your presentation, but I wanted to ask again, do you start with allowing students to ask the big general why questions and then help them formulate investigative questions? So could I ask you to say a little more about that step? You know, sort of how do you choose a good investigative question to start with? How do you help teachers know the difference, and how do you help students sort of see the difference and go from the big to something that is more productive?
Anna or myself, or who wants to answer?
I can answer.
Go ahead.
The inquiry question is as in research, the scientists make some question. The good question will develop in something incredible for science or not. So one of the point during the PDI is try to make the teacher that they understand what is an inquiry question and what not. Normally, the inquiry question is a question with to answer this question, you have to collect data, you have to show evidence. This is the point. It's not just yes or no. And you can use it during the PDI. We use some videos, for example. How can I start with the brainstorming? But the brainstorming is something that you go around. You have inquiry approach is something very refined. So you know where you go before. And then you have to do, for example, you have to ask your students to have a list of questions about some topic, some general topic, and then you have to discuss with them which inquiry question can be investigated with the material that you have available, for example. This is a way. So in this way, you drive your students and support on the question that you know that is investigable question for them. Of course, and as Mariangela said, the question has to be very focused, very simple, simple word, very clear. Because sometimes we are afraid that our students don't understand us, but we pose the right question. This is the point. They cannot investigate something that is not investigable. And don't worry, there are a lot of strategy that you learn to transform a not investigable question in investigable question.
I love that. And I want to thank you so much. We're running out of time. We do have a last question here, which is sort of putting the program office on the spot. Is there any talk about making inquiry the default for the ABE labs? And it's a wonderful question. Thank you for throwing that bomb out there right at the last minute. But it is something that the program office has been talking about a lot with program sites. And program sites ultimately make the decisions about what kinds of labs are implemented. However, we are looking to integrate inquiry in many more of our new curricula as that comes out. We have a scientific inquiry working group that is actually that convenes from our program sites that is exploring how we can do this. In the meantime, we're really certainly seeking to share as many of these strategies that program sites have developed for integrating inquiry as Italy has done and is sharing with all of you. So I guess my short answer would be watch this space. And we're going to continue to evolve the ABE curriculum as new pocket lessons and new topics come out, and we explore those. I've mentioned that we'll have the inquiry-based science education course, courtesy of ABE Italy, who is opening that up to our entire global community. So we're incredibly grateful to them, not only for their sharing of resources, but for their time today. So Anna, Chiara, Mariangela, and Luigina, I just want to say thank you again. This is nighttime in Italy, and they are doing this after hours. And so, as always, we really appreciate your energy, your passion, and bringing this to all of us so we can learn from you. So thank you for being here today. And thank you to our participants.
Thank you for having us.
Thank you so
Thank
much,
you for
everybody.
having us.
To our
It's been a
participants.
pleasure. Thank you.
Yeah.
Thank you all participants. It's been a great night for us.
And we will post the recording. And for all of you who have joined us, we were and registered for this roundtable, we will send to you the video, and we'll send the resources that the team will provide for us. And we hope that you'll continue to go back to it and use it as a classroom resource. So keep the questions coming. If you have a roundtable topic you'd like to learn more about, please send it to the program office. And we would love to hear from you. If you can put the address for the ABE program office in the chat, Amy, that would be wonderful. We appreciate your time today, everybody. Have a great rest of your day.
Ciao.